Hello everyone, today we're going to be working on example 6-1 and this example is asking us to determine the force in each member of the truss shown below. Also to indicate whether the members are in tension or in compression. So before we begin, I just want to remind everybody that if we end up calculating a positive result for the unknown bar force, it means that our bar will be in tension. Meanwhile, if we calculate a negative result for the unknown force, that means that our force is in compression, meaning that it's going to shorten the bar, and if it's in tension, it's going to elongate that bar. So to start off this problem, what we're going to do is first we got to determine how many unknown reactions there are. So looking at the figure, we have at point A, we have a pinned support, meaning that we're going to have two reactions, that vertical and horizontal reaction. I'm going to assume here that A sub y is acting downwards. And I'm going to assume that our X reaction is going to go to the left. And then here we have a roller, meaning we're just going to have that vertical reaction. And I'm going to assume that this one is going upwards. So now that we've determined how many reactions we have, now we're going to proceed to finding them. So the first step was reactions. So now we're going to determine the values of them. I'm going to start off with our forces in the X direction. So from here, we only have the 500 newtons that's going to the right. And then we assume that our A of X is going to the left. So we have positive 500 newtons minus A of X, since we assume that a reaction would be going to the left. We know that has to equal 0. So we end up getting that A of X is equal to 500 newtons. And since we got a positive number, that means we assumed correctly. So we know that that reaction is going to be going to the left. Now, the next thing that we're going to do is I'm going to be taking the sum of a moment about a point, since we have two unknown vertical forces. So what I'm going to do is I'm going to take the moment about point A, so that way I could solve for C of y. So sign convention, counterclockwise positive, the sum of the moments about point A has to equal 0. We know that A of X will not be creating a moment, nor A of Y. So the only two forces that are going to be creating a moment is our 500 newtons and that C of Y. So remember, moment is equal to the force times the distance. Our force is of 500 newtons. Our distance is this 2 meters right here. And since this force is acting to the right, we know that's going to be creating that clockwise moment, meaning a negative moment. So we have a negative moment of the force 500 newtons times the distance of 2 meters. And then from there we have our C of y that we assume that it's going to going upwards. That means it's going to be creating that counterclockwise moment, meaning a positive moment. Our force is what we're trying to determine, and then our distance is once again going to be 2 meters. So this time we have a positive force of Cy times 2 meters. We know that has to equal 0. So we end up getting negative 1,000 Newton meters plus 2 Cy is equal to 0. And if we solve this for our reaction C of y, we end up getting that C of y is equal to 500 newtons. We ended up getting a positive number, means that we assumed correctly. So we know that this reaction is going to be going upwards. And now we just have to determine our a sub y. So now we can find it by taking the sum of the moments in the y direction. Sorry, the sum of the forces in the y direction. So upwards positive, we know that the sum of our forces in the y direction have to equal 0. So here we assume that a sub y is going downwards, so that's a negative force, and then c of y, we found out that it is going upwards, so that's positive. So negative a sub y plus 500 newtons has to equal 0. We end up getting that a of y is equal to 500 newtons, positive number, so we do know that it's going to be going downwards. So now that we know the values of our reactions, we're going to go ahead and replace it with the forces. So now that we determined the reactions, now this is where we're going to start actually determining the forces of each of the members of the truss. So to determine the forces of each of the members, what we're going to be using is the method of joints. So that's our second step. I'm going to move my work of the reactions off to the side. And now we're going to do method of joints. That's our second step. So second step would be using method of joints. So remember, when you use method of joints, the only thing that you guys want to keep in mind is that you want to be choosing joints that have no more than two unknown forces, or yeah, two unknown forces, because if you have more than two unknown forces, it's gonna you can't really solve it. So we're gonna take a look at this. For example, if we were to start off with joint B, we'd be able to do it since we have only two unknown forces. So we could do that. If we were to start off with joint A, we could also do that because once again, we only have those two unknown forces. Joint C, we could start off with joint C, but we don't really have anything to work with. As you guys could tell, like, sure, we only have two unknown forces, but we don't have like another four. Well, in a way we do. Sorry, I forgot about this 500. So you could also start off with that one if you guys would like. But just to make things easier, I like looking at it like a quick overview, and I was like, I'm gonna start off with joint A, because if I start off with joint A, I could already determine this one, and then from there, when I proceed to joint B, I'd be able to determine this one, and then from there, I wouldn't have to do joint C anymore, because we would already determine those two. So I'm gonna start off with joint A. So we're gonna draw our joint A. So this is our joint A. We have 500 newtons coming down. And then from there, we have the 500 newtons going to the left. And then from joint A, we have two members, two bars coming out of that joint A. As you can see, one that's going vertically and one that's going horizontal. I always like to assume that our forces are going to be in tension. So that's just what I'm going to start off with. I'm going to assume that they're going to be in tension. And I'm going to call this force. This vertical one, since this bar is going from A to B, I'm going to call it force AB. And then this one, I'm going to call it force AC. So force AB, this is force AC. So now that we have this joint, now we're just going to determine the value of these forces just by taking the sum of the forces in the x direction and then in the y direction. So you guys are going to see why I decided to start off with joint A. So I'm going to start off with the forces in the x direction. We know that the sum of our forces in the x direction have to equal 0. We have our negative 500 newtons. And then from there, I assumed that our force AC was going to be in tension. So that means that it's going to be positive. So 500, sorry, not 500. I'm getting ahead of myself. Force AC has to equal 0. We solve for the force. So force AC is equal to 500 newtons. Now remember what I said earlier. Usually when we find for reactions, what we do is we end up changing the signs if we assumed incorrectly, right? But for here, you don't want to do that. Because remember, the example is asking us to indicate whether the members are in tension or in compression. So here we got a positive number, meaning that it is going to be in tension. So we have 500 newtons in tension. So you're just going to put that T right next to it. And then from there, if it would have came out negative, you would have just put a C or indicated that that one's going to be in compression. So this is one of the forces of the truss, one of the forces of the members of the truss. Now that we figured out force AC, now we're going to determine force AB by taking the sum of the forces in the y direction. We have negative 500 newtons again, and then like I said, we assume that the forces are going to be in tension, so we have a positive force AB is equal to 0. We solve for force AB, and we end up getting that force AB is equal to positive 500 newtons. So once again, that bar is going to be in tension. Okay, so just quickly here as you guys could see, they give us two figures to work with. So here, I'm just going to be checking off like the bars that we start finding that we found their values for. So now, as you can see, we only need this member to find. We could either find it by using joint C or joint B. You don't have to do all the joints, as you could see. So I'm simply just going to choose joint B. You could also choose joint C. It does not matter. So now I'm going to do joint B. Once again, sketch it out real quick. This is our joint B. We have 500 newtons acting to the right. And then remember, we have this bar coming out. And remember, we already determined the value for that. So, and since it's in tension, we know that it's going to be going away since it's in tension. We have 500 newtons. And then from there, we have that unknown force that we're trying to determine. Force, I'm going to call this force BC. So now that we have that, remember when we would determine the forces, and we since when they were in to an angle, we would determine their x value and their y value. Well, we're basically going to be doing that. So as you guys can see, we're basically, as we continue, we're just adding on to what we've already learned. So looking at this sketch real quick, we could see it's given to us that this angle is 45, so we know therefore that this angle right here is 45 as well. If you guys didn't know that, it would have been just easy just to go off joint C, since you know for sure that this angle right here is of 45 degrees. So we have this angle of 45 degrees. And I'm just going to determine the value of the force from its x component. So I'm going to be determining the x component of it. So we're going to be taking the sum of the forces in the x direction. We know that has to equal 0. So we have positive 500 newtons. From there, remember, I'm assuming that all of our forces are in tension. So from there, we have that positive force BC. And then remember, we're trying to determine the x component of it. So as you guys can see, if this was a triangle right here, what we're working with is the adjacent side and the hypotenuse side. So we'd be using cosine. So force BC times cosine of 45 is equal to 0. You could have done force of BC times sine of 45, but remember, then you'd have to be taking the sum of the forces in the y direction. So from here, we would just solve for force BC. We end up getting that force BC is equal to negative 707.1 newtons. So in this case, we got a negative number, so that means that it's going to be in compression. So now we could go ahead and check off that we determined that force in the bar BC. So now that we have everything, this is where the second figure just comes in quickly. Remember, it's asking us to indicate whether the members are in tension or in compression. So how I like doing it is I like drawing a little line coming out of it and then just putting the value. So we have this bar has a force of 707.1 newtons in compression. From there, you got this bar of 500 newtons in tension. And then from there, we have another bar of 500 newtons in tension. And with that, we are done with this example. So remember, the first step you want to do is you want to determine the reactions. How many reactions do we have in this figure? And then you're going to solve for them. Once you have solved for all the reactions, then you're going to be using method of joins. Remember, you just want to do that quick scan. Which one has no more than 2 unknown forces, and which one would be easier for me to work with? Because look, since we did joint A first, we were able to determine 2 while using one joint. So that's why I really started with joint A. So it's just preference. Just remember, you can't have more than 2 unknown forces. And then from there, you just go determining all the forces of each of the members of the truss. And then remember, positive number, tension. Negative number, it's in compression. Thank you guys so much for watching this video. Please feel free to like this video if you guys enjoyed watching it. And also please feel free to subscribe to our channel if you guys would like to see more videos like this.